Virtual reality head-mounted displays offer the feeling of immersion in a virtual environment. However, they highly depend on users' visual and auditory senses but lack haptic sense. Therefore, how haptic sense could be offered in a virtual environment is a paramount topic for VR technology advancement. In this study, we investigated whether weight illusions in VR occur as in the real world, in a situation where only the appearance of virtual objects is manipulated without haptic feedback. In the real world, the size of an object affects weight perception. When people compare the weight of larger and smaller objects of the same weight, the smaller one feels heavier. This illusion is called size-weight illusion. This happens because people typically estimate the weight of the larger object to be heavier. Consequently, they generate excess muscular power to lift it. On the other hand, they generate a little muscular power to lift the smaller one. As a result, the smaller object feels heavier. Also, the brightness of an object affects its weight perception. This illusion is called brightness-weight illusion. For the same reason as the size-weight illusion, people overestimate the weight of a brighter object when compared to a darker object of the same weight. The weight perception is also affected by the object's material. This illusion is called material weight illusion. A heavy-looking material such as metal feels light. Conversely, a light-looking material such as wood feels heavy. In this study, we investigated how these weight illusions in VR produce weight perception. Size-weight illusion. Brightness-weight illusion. Material weight illusion. In the experiment, we investigated how size weight, brightness weight, and material weight illusions could be induced in VR. Participants compared the weight of the objects. As a result of our experiment, in the brightness weight illusion, the heavier-looking object, the darker black object, felt heavier. This means that the effect of the brightness-weight illusion in VR contradict those in the real world. Also, the material weight illusion showed the same pattern. The heavier-looking object, the metal one, felt heavier. However, the size-weight illusion showed a different pattern. The lighter-looking object, the small one, felt heavier as in the real world. The main findings of this study were: first, brightness and material weight illusions did not occur as in the real world. There is a possibility that due to the lack of haptic feedback, participants' expectations might be directly reflected in weight perception in VR. Second, size-weight illusion in VR occurred as in the real world. This result appeared to be caused by the uniqueness of the size-weight illusion, that is, qualitatively different from other weight illusions. This study demonstrated how weight illusions occur in VR without haptic feedback, and classifies weight perceptions and the robustness of the illusions. The results of this study can help clarify human perception of weight using weight illusions in VR. The use of weight illusions has a lot of potential for producing various kinds of user experiences.